All right, welcome back. Starting Module 3 today, and we're going to be talking about angle relationships formed by a transversal. So to start off, we just got to know what a transversal is, and that is a line that intersects two or more coplanar lines at different points. And I've got an example down here in the right-hand column where line T is a transversal because it's crossing two or more lines. And when that happens, you create a bunch of angles, and I've got them all numbered here. And there are names for these angles, which I've got listed over here highlighted. You've got corresponding angles, which are kind of angles in the same position. So like angle 1 and angle 5 would be an example of corresponding angles. Angle 1 is kind of the upper left angle there, above line J, left of the transversal. Same with angle 5, above line K, left of the transversal. So we would call those corresponding angles. And in that picture, there are four sets of corresponding angles, which I've got listed over there as my examples. Then you move on to alternate interior angles. Now, alternate interior angles, they are non-adjacent, and they're in the interior. So if you think about interior, that would be like inside your two lines. This would be exterior angles out here, angle 1, 2, 7, and 8. So alternate interior angles, alternate meaning they're on opposite sides of the transversal and they're in the interior. So like 4 and 6 would be an example of alternate interior angles. They're non-adjacent, they're not next to each other. So don't pick out like angles 4 and 3 because that's actually a linear pair. Those are not alternate interior angles. Then you got same side interior, which would be like 4 and 5. They're on the same side of the transversal and in the interior. And you can do the same thing with exterior. So you got alternate exterior angles like 1 and 7 or 2 and 8. They're alternating sides of the transversal and the exterior. And then, of course, same side exterior would be like 1 and 8. They're on the same side of the transversal and they're both on the exterior. So that's just kind of a little lesson on what these angles are called. We'll talk about their relationships here a bit later. But I just want to make sure we're okay with that. So I've got a few practice problems. If you'd like, you can pause the video here and try these on your own. Otherwise, I'm just going to kind of run through each one. So it says, give an example of each angle pair. So corresponding angles. You could go with angle 1 and angle 5. Although there are actually lots of options like 2 and 6, 3 and 7, 4 and 8. All those are corresponding angles. For B, alternate interior angles, you could go with angle 4 and angle 6 would be a good example. You could have also said angle 3 and angle 5. For alternate exterior angles, you have angle 1 and angle 7 is what I'm going to go with. You could have also gone with 2 and 8. And lastly, same side interior angles, I'm going to go with angle 4 and 5. Although you could have said angle 3 and 6. Moving on to the second section, identify the transversal and classify each angle pair. So now you've got 3 lines. Every one of them, line L crosses 2 lines, line N crosses 2 lines, line M crosses 2 lines. So they're all transversals, but we're going to pick our transversal dependent on what angles we're talking about. So like in number 1, we're talking about angle 1 and 5. So in that scenario, line N would be our transversal since it has since it's forming both those angles. It's part of the formation of both those angles. So line N would be your transversal there. And that would make angle 1 and 5 alternate interior angles. They're in the interior and they're alternating sides of that transversal. So alternate interior angles. Go on to B. We're talking about angles 3 and 6, which would make line M the transversal. And 3 and 6 would be corresponding angles. You can see 3 is below and to the left of the transversal. 6 is below the line and to the left of the transversal. So those would be corresponding angles. And lastly, angle 1 and 4, line L would be your transversal. And 1 and 4 would be alternate exterior angles. So hopefully you got that. That just comes from the definition, knowing what those types of angles are. A couple more things to add, and then we're going to talk about their relationship. So if you look at this picture, you've got 2 parallel lines, and they're intersected by transversal T. Now, I want to point out one important detail, and that is to look for these arrows, because those are kind of like markings, like we've talked about tick marks before. We've talked about arc marks before. Tick marks and arc marks both talk about a visual indicator to show something's congruent. If you have arrows, they are to show that lines are parallel. So keep an eye out for those. So if you look at this picture, angle 1 and 2 are a blank, and that would be a linear pair. They are not any of the new definitions we put together today, but they are a linear pair, which, as a reminder, are a pair of angles that are adjacent and form a line. So if you put those together, they would form a nice line there. 5 and 7 are vertical angles. Of course, vertical angles are congruent. We should know that. And then lastly, angle 1 and 5, they are corresponding angles, which is what we talked about today. And then the question is, what else do you think is true about angle 1 and 5? And this is really up to you, but most people say that they think 1 and 5 are equal or that they're congruent. And that would actually be correct. They actually are congruent when they're on parallel lines, which takes us to our 5 postulates and theorems we're putting in today, which is, if you have parallel lines, and every one of these starts with if two parallel lines are cut by a transversal. Every single one starts off with that. That's our if-then statement. We've talked about that formatting, our conditional statements. So if two lines are cut by a transversal, if two parallel lines are cut by a transversal, then all these things are true. And I'm going to underline the big ideas. First off, if two parallel lines are cut by a transversal, corresponding angles are congruent. Alternate interior angles, also congruent or have the same measure. Same side interior angles are supplementary. Alternate exterior angles, same measure. And same side exterior angles are supplementary. So if they're same side, they're supplementary. Any of the others, they're going to be congruent or have the same measure. So that's kind of an easy way to remember that. But again, to do any of these, you have to have parallel lines. And I'll point out one other thing here is that the corresponding angles is a postulate, not a theorem, meaning we can't prove it. We just accept it as true without proof. That was back from Module 1 when we talked about what a postulate was. In fact, we've done 2 postulates already. We've done the segment addition postulate and we've done the angle addition postulate, so that should not be a new word to you. And we're actually going to prove one of these theorems. I'd like to prove them all, but we're just going to have time to prove one because they're all about the same. So I chose to do the alternate interior angle theorem, which says given A is parallel to B, and again, you can see the arrows over here. That's a good indicator because you can only do these if lines are parallel. And that's what we're going to start off with for our first statement. A is parallel to B, given. And then since that's all the information we could really pull from just that particular statement, we really need to look at the picture and say, is there anything else we know? And you may come up with angle 1 is congruent to angle 2 because they are vertical angles. So that would be the vertical angles theorem. And then you could also say that angle 2 is congruent to angle 3 because that is our corresponding angles postulate. Those are corresponding angles and they're on parallel lines, so they must be congruent. Which means that if your corresponding angles are congruent, 2 and 3, and we've already said that angle 1 is congruent to angle 2, we can cut out that middleman and just say angle 1 is congruent to angle 3 because of the transitive property. Remember not to use substitution there because there is no substitution property for congruence. And you've proved the alternate interior angles theorem. 1 and 3 are alternate interior angles. They'll be congruent when they're on parallel lines. Now, the nice thing about this is in the future, if you see that you have parallel lines, you're going to be able to go straight to number 4 and just say, hey, I know angles 1 are congruent to angle 3. Your reason will be different. You'll say that's because it's the alternate interior angles theorem, now that we've proved that. And that would be really how you prove almost every one of these theorems right here. You might have supplementary in there, but that's the same. It's going to be practically the same proof. Okay. So let's put it to use. Here's what your homework's going to look like. This is a word problem. It says in 1791, Pierre Charles L'Enfant designed a plan for Washington, D.C. His plan included a grid of streets with avenues running diagonally across the grid. Look at the map of Washington, D.C. 12th Street and 10th Street are parallel. I'm going to draw in arrows just to show that those are parallel. And it's intersected by Pennsylvania Avenue, which is acting as the transversal in this picture. And we want to find the measure of angle 1 and the measure of angle 2. Now, if you look at these two angles here, one of them is 110 degrees. They are same side interior angles. And since they're on parallel lines, same side interior angles should be supplementary, which would make angle 1 70 degrees. If you look at 110 and 2, they're also on parallel lines. Those are alternate interior angles, which means they should be congruent according to our theorem, which means that angle 2 is 110 degrees. Alternatively, if you knew that angle 1 was 70, 1 and 2 are a linear pair, so they should be supplementary as well. Excuse me. All right, so that takes us to a couple other problems. Again, you can try some of these on your own. Find each angle measure, so find a measure of angle EDF. Now I'm looking here, we've got 125 degrees for angle ABC. Those are alternate exterior angles, and I can see that they're on parallel lines, so therefore they must be congruent, which means EDF is also 125 degrees. If you go on to angle TUS, angle RSU, these are both same side interior angles. They're on parallel lines, so they should be supplementary, which means we're going to have to do a little work here to figure out what x is. 13x plus 23x equals 180. That's 36x equals 180, which means that x is going to be 5, allowing us to figure out TUS is 115 degrees. Last but not least, angle ABD. Now, it's kind of hard to tell what angles these go with, but I'm going to draw some little arrows to help you. 2x plus 10 and 3x minus 15, those are alternate interior angles. They're on parallel lines, so they should be equal to each other. Subtract 2x, get x. Add 15, you get x is 25. And then we can plug that back in to find angle ABD, which would be 60 degrees. So try your homework, see if you have any questions, and we'll see you tomorrow.